Hello, myself Nilad Krishna. This machine learning project is a part of virtual internship program organized by AINE AI. I am from November 2021 batch. So the objective of this project is to reduce monthly churn by identifying high-risk customers of a telecom company. The telecom company is facing hardship for maintaining its customer base in the market. So in order to sort out this problem, I have used machine learning. So the data set is given by the VIP AINE.ai company itself. First of all, loaded the packages NumPy as NP, Pandas as PD, Seaborn as SNS, Matplotlib, PyProd as PLT, and after that, SciPy, Scientific Python from SciPy library, import stats. So remove filter warnings, I import ignore as well. So the first of all, I read the CSV file from Pandas data frame pd.read under CSV telecom data. Here is the data frame. It has 51,047 rows and 58 columns. Or now starting from the analysis, first of all, analyze the shape of the data frame. It has 51,047 rows and 58 columns, and the target column is a churn. We have to identify whether the given existing customer is churning, will churn or not. So, applying the value counts function, it will display the number of non-churners and churners to categorize the values. So as can be seen here that the data set is imbalanced because the number of churners is quite very less as compared to non-churners. To first step is to data cleaning step, missing values, outliers, unexpected value, etc. So there are customers that have 0 monthly revenue. To filter out that, I've applied the data frame concept. Cust underscore df monthly revenue is greater than 0. So I'm so it to filter out the data rows based on these conditions. So there are 6 rows that have 0 monthly revenue. So I have to filter out these rows. Now to calculate the percentage of missing values, cust df dot is null dot sum upon cust df dot shape. 0 indicates the number of rows. We have to divide the null values divided by number of rows, multiply by 100. It will display the missing percentage wise missing values in each column of the data frame. So there are very less missing values, even around 1.7%. As the missing values in each column very less, we can simply drop that row. Imputation is needed when the columns containing the data is very important and missing value percentage very high, say around 40 to 50%. So we are dropping the unnamed rows, the rows containing the null values. And in place equals to true, it means we are saving the data back to the original data frame. After that, is null dot sum function apply again. So there are no null values. Regarding the unique subscriber and director assisted calls, I have created a box plot as the number of outliers are quite high in both of that. So it's quite difficult to find the median in both the cases. So filter out 1% outliers from the above mentioned 2 columns. I have taken quantile function of 99% of the data I have to take. So the 99% data of the unique subscriber column is 5.0 and director assisted calls is 9.65. As we have to remove the top 1% data in the firm outlier from the above 2 columns, this means we need to take only 99% quantized values into consideration. So accordingly, apply the filter method. Sorry, actually filtering the data based on these conditions. Cust df unique subscriber less than equal to 5.0, and this statement code will represent only those rows which satisfy both these conditions. So now in the box plot looking, we can identify the median from these box plots. After that, there is a scatter plot. Find the relationship between two variables. X is the monthly revenue and the overage minutes from the same data frame. It shows a increasing trend. As can be seen from the scatter plot, that there exists a positive correlation between monthly revenue and the overage minutes. And again, it's a cat plot between active subscribers and monthly revenue from the same data frame. As the number of active subscribers increasing, the monthly revenue of the company goes decreasing here. So it's a increasing number of active subscribers leads to decreasing monthly revenue. So it's the interpretation from this plot. Another question is, credit rating have any impact in the churn rate? As can be seen from the cross tab for both the axis row wise and column wise. Based on the different categories between no and yes in the churn, there are one highest rating customers and from lowest rating customers. It seems that the customers are churning irrespective of their credit rating, and proportion of churned customers is large on high credit score. So there doesn't shows any strong correlation between these two variables. To explain the analysis further, a wrapper function is created. So regarding feature engineering part, we have to create some more features which helps out in model training of the machine learning class. So like percentage of active subscribers, because active subscribers upon unique subscribers, percentage of recurrent charge, percentage of overage minutes. Basically, we have divided most of the variables by monthly minutes to derive new variables, new columns. Percentage dropped calls, percentage of blocked calls, percentage of customer calls, and we applied the function to the same data frame. After that, applying the .info method, it will display the data type of the columns and the non-null values. Data frame has this data type of float 64, empty 64, and object type. Now separating the continuous column from the and categorical column, I have applied the list comprehension method. And after that, after separating the two different lists for continuous and categorical column, remove some unwanted columns like service area. Churn is a target column. Customer ID we need at last for training the model and testing and the testing phase. Now, based on the chi-square test, it's a statistic based test to find which variable has an most impact on the target variable churn rate. Actually, churn is the column present in the data frame. It helps out to filter the categorical value that has no impact on the churn. So to do this, I've created a function here. Two parameter custom df and categorical column. I created an empty list, new cat column. I'm applying the for loop in the categorical column list. So we are checking each column and comparing it with the churn to identify if its value is greater than 0.05. If it has value greater than 0.05, then this it will pass out. Nothing will be executed. And if as condition satisfies, then that column name will be appended to the new cat column list. So apply the categorical column. Check categorical IMP function that we have derived here, so that only important categorical columns will get in the new will be taken as categorical column in the list. As it can be seen here that the churn has a imbalanced data set because the no and yes are not of equal values. So if we try to train our model with these y values, churn values, then model may get biased towards a greater number of values, like the number of non-churners were high. So model will be biased towards that and may leads to overfitting and some other problems also. To minimize this, we have to apply oversampling. I've applied oversampling here. Some other methods are also available. So in the oversampling, first I change the churning of yes or no to replace with 1 and 0. Because the machine learning model accepts only numerical values. And after that, class count 0 and class count 1 to find out the number of values in the satisfying the 0 in category in the churn and 1 category in the churn. After that, class 1 over, for example, class count 0 values will be oversampled with class 1 over to balance the sample in both the yes and no conditions. Then applying the y value counts upon len y to find out if number of samples got balanced or not. After that, I have applied the important categorical column to find out those categorical column which are important got saved in this list here. After that, I applied the continuous column to find the null values in the continuous column list. I have taken the number of columns as a list here, but it shows the data frame x dot shape 0, and so it is showing there are some null values or AINE values or infinity values exist in the newly derived features. So although the number of missing values or infinity values are very less in the derived features, but we can't drop that because these are the derived features. It helps in the machine learning training task. So I'm imputing these values with the mean of the values of the columns respectively. So here is the code. In place equals to true, I have applied so that the original column will get replaced. After that, I again applied x is null dot sum. So it shows no null values. But there are some infinity values present in the continuous column. So first I replace the infinity values with AINE values. After that, I replace AINE with mean of the values again. Now come to the pre-processing part. From the scikit-learn library, imported train test script to test the data into training phase and testing phase. Taken test size of 30%. 30% data will be used in the testing, and 70% will be used for training. Taking a random state to some value, because if we don't take random state, every time we execute the code, it will show different results. So random state should be equal to some value, numerical value. After that, from a scikit-learn pre-processing part, importing a standard scaler. The purpose scaling here is to bring all the columns into a particular scale here, so that if one of the column values are quite larger as compared to others, it will dominate the machine learning model. So the pre-processing standard scaling is applied here. First for the continuous column with transform, and as the machine learning model accepts only numerical values, so regarding categorical columns, I applied get dummies function to convert the category into numerical values. Same is applied for the testing data. After that, train the model using logistic regression algorithm From the scikit-learn's linear model library, import the logistic regression algorithms. And from the matrix library, imported the accuracy score classification report, confusion matrix, receiver operating characteristic curve, F1 score, and plotting confusion matrix, average precision score. These are the metrics that I will use to assess the model performance. So this is a logistic regression, a random state taken at 0 and fit method applied to train the model. After that, I find the probability prediction of the churners here. Those are churning telecom company, those customers, to identify those customers. After that, using the same model here, I've applied the testing phase in the test data set to predict the test output. Now, actually, the output here is taken as the probability value. So we have to take a cutoff value to identify, to separate the churners and non-churners. So to do this, I import a copy library here, then I created a function here, best cutoff, using the for loop and taking the deep copy from the copy library, so that the another object or copy object is created, but not the original will be used. So for predicted x values greater than or equal to I by 100 means we are taking iteratively the values between 0 to 101. If equal to those values which are greater than or equal to I by 100 will for this one will be saved here, and for less than I by 100 0 will be saved here. So in this way we are separating the churners and non-churners here based on the probability value. After that, I created a plot here, probability cutoff F1 score will be these are two variables which will be used to find out the values from best cutoff. So I have taken 0.4 as a cutoff value to separate churners and non-churners. This is for the training data set. So 0.4 up to 0.4, there will be increasing or stable, but after that it goes on decreasing here. So 0.4 will be seen as optimum. For the testing data, it shows the similar trend here. After that, using the metrics, classification report, receiver operating characteristic curve value of the churners. And for that, true, negative, false, positive classification confusion matrix, true, negative, false, positive, false, negative, and true, positive. These are the, it's kind of tuple and packing. So confusion matrix method is applied here for white test and the predicted value. So the model indicates accuracy of 0.55. The model is able to classify some data, but it's not a very good score. So, so we have applied another machine learning algorithm, random forest, from scikit-learn of ensemble method. We have imported random forest classifier based on trees, the number of models. So these are the parameters that I have taken for initialization first. So maximum depth of the tree is 15, minimum samples is 50, random state this one. Criteria is taken in entropy, and estimators number of trees taken as 400, and jobs equal to -1, shows that all the processor cores are should be used in the model training phase. After that, not fit, extend, or white trend, training the model. And after that, predicting probability value of the training data set for the churners first. After that, predicting probability for the test data set using the same matrix, same plotting method that I used in the logistic regression. This time I have taken 0.5 in both the cases to separate churners from non-churners. Here is the trend here. So after that, the graph shows inflation here. After that, it goes on decreasing for training set and for the testing set. And now replacing with all the predicted probability value less than 0.5 as non-churners and greater than 0.5 values are equal to is taken as churners. Calculating the same matrix here. The random forest model performs better as it has an accuracy of 0.73 and 73%. So, and regarding classification score, it has a true positive value of 8218, true negative is 7037. The purpose is to minimize the false negatives. So false negative value is showing less here. So the model, although is a model performing better than the logistic regression model. Random forest classifier has better accuracy than logistic regression. Here it has better receiver operating characteristic curve score than logistic regression, and has a greater number of true positives and true negatives than logistic regression. And so the most important features that are impacting the churn of a target variable. So we have to plot here. First of all, a series is created from this random forest classifier feature importance. Index is taken and the extrain columns names, plotting a figure size of 5,10. The title of the plot is feature importance plot, taken as 20 important largest features, sorting these values and plotting the horizontal bar plots. So the current equipment days shows the greatest impact on the churn rate. And so it is in a decreasing order. Now we have to apply the model on the brand new data set that has been provided here. So first I read the data set as pd.read_csv and finding the null values. As customer ID and churn is of no importance here right now because we have to find the churn of the customers, and customer ID is there is no null values. That's it. So percentage change minutes has very little less values, null values. Regarding percentage wise, null value is very less, maximum around 1.675%. So first I'm separating the I'm actually dropping the customer ID and churn column from the on this data set XF, taking churn as the final target variable here, using the same list comprehension technique, separated continuous column and categorical column. And after that, applying the create features to create new features, feature engineering. After that, to finding the information about this data frame. These are the new features that are created here. It has some null values. So filling with null values with mean of that column in the original data frame. After that, dropping the service area as this column has no use in the machine learning model. So after that, xf.info, all the null values has been filled out. So there are no null values here. After that, regarding continuous column, applying the fit transform method to scale the data set. In categorical column, we have to get dummies as that I have done before. but after applying a standard scalar, there are some infinite values. So regarding infinite values, I've first converted into NaN values. Then after that, I applied the mean, replaced that NaN with the mean of the values of the column. But for the training purpose, we cannot directly apply this data set, as there are less number of features in the brand new data set as compared to the training or testing of the previous data frame. So to resolve this issue, first I created a set of train dot columns for the previous data set, taking intersection with the converting xf dot columns into set form, so that only columns will be taken as in the new set that are common here. Converting the set of the columns into list and apply that xf the list here, so that only those columns in the brand new data set will be used for training that were used in the previous data frame for the training of the model. After that, I applied the predict method to find the prediction of the data set, to find out which customers will be churning and which will not. So creating data frame of customer ID, the customer ID of the brand new data frame, the churn value that we have received here. So this is the data frame, customer ID, and will it churn or not. It has 20,000 rows and 2 columns. After that, for calculating a lift chart and total monthly revenue saved for we're targeting 20% customers using best predictive model. So here best predictive model is the random forest classifier. So to first calculate the lift chart, I have to install scikit-plot here, because the scikit-plot is needed for this. After that, I have predicted probability is X testing data from the random forest classifier. Then using the skplt.metrics, plotting lift curve here. Y test and Y predicted. So Y test here and target probability. Y predicted here, target probability. So here is the lift curve. Now for 20% of the probability value for the churners, the lift value of 1.8. And for monthly revenue, first of created data from for monthly revenue, X test data set, and predicted probability is taken as the column names, target probability of churners here. After that, the new data frame that I created, I have sorted values here. I predicted probability ascending to false and in the decreasing order. So these are the predicted probability values of the churners. So monthly revenues here in the will be less. So thank you for taking time.